Hello students, today we will see a law of conservation of mass. Okay, so what is law of conservation of mass? Have you heard about law of conservation of energy? So what is that? That is energy cannot be created, it cannot be destroyed, right? The same thing applies for mass also. So how do you define law of conservation of mass? So according to law of conservation of mass, the mass cannot be created or it cannot be destroyed by any chemical reaction. See, it's given neither created nor destroyed by any chemical reactions or physical transformations. So that means when you have a chemical reaction, the mass of the products and the mass of the reactants, they should be same. So mass of the reactant should be equal to the mass of the product. So that is the reason you say always chemical equations need to be balanced. See, let's take the left side is reactant and right side is product. So before the reaction, what is the mass? After the reaction, what is the mass of the product? They should be same. They should be balanced according to law of conservation of mass. See, look at this example. So again, we have repeated the definition for law of conservation of mass. So according to this, already we know that it should start and end with the same amount of start and end with same amount of components or substances. Look at this example. We have log 30 kg and you're using fire 1 kg and the product you see smoke and you see ashes. So you know when you see the mass for the reactant, that is 31 kg, and you will be getting the same mass of products. So 31 and 31, they are same. Okay, this is an example for law of conservation of mass. And look at this one more example, like in so before and after, they are same. That's what they are showing. So you see the blue solution reacts with yellow one and it gives the green one. So this mass, blue mass plus yellow mass, should be equal to the green mass. Look at this pictorial presentation. See, before the reaction, that is 300.23 grams. Then after the reaction, and you have the precipitate in a sodium chloride solution. Still, the mass is, see, if you look at this one, the mass is the same. See, during this reaction, mass is 300.23 grams. Before and after 300.23 grams. So they are same. I want to show you a video for this. Then after the video, we'll work a couple of problems.
What does conservation of mass look like in the lab setting? So we're going to do the same experiment that you did a couple days ago. We're going to use some Alka-Seltzer tablets, and we're going to put them each into these flasks. If you look right now, almost identical or pretty close to the same mass. Now, one of the things that I'm going to do, however, is add a balloon to the top of one of them, and we're going to leave the first one the same. So I'm going to take this tablet and I am going to crush it up. Put it in the balloon. And without putting it into the water, I'm going to put it on the top. And then seal that up with some tape.
Can you guess why he's sealing that balloon with the conical flask with the tape? So what he's trying to stop? Can you guess? Yeah. So there are some gas, there is some gas going to form during this chemical reaction. So he doesn't want the gas escape from the system. So that's why he want to secure so that the gas formed it will not escape from the conical flask. It's completely trapped into the balloon. So that's why he's sealing the balloon with the conical flask with the tape. Nice try.
All right, now I will tell you right now that is not going to be perfect, but that'll do well enough. All right, so we have pretty close masses. One of them reads 134 and the other one reads 128. It's now a little bit heavier because it has that balloon on top of it. And we are going to take this Alka-Seltzer and we're going to also just put it on the scale because we're going to put that in, right? And so now we're at 131.6 without a balloon, and then 134.04. And again, it's a little bit heavier to start because it has that balloon on top as well. So what we are going to watch is there a difference in the mass? Okay, so we're going to add both of these into the water, and we're going to get the reaction to start. And what you should see pretty quickly is that following the conservation of mass here, the Alka-Seltzer that has no top on it right here is steadily going to be dropping in mass. Why is that happening? It's still following the conservation of mass. That gas is escaping and is going into the air, that carbon dioxide gas. And so some of the products are still in that beaker right now, that Erlenmeyer flask, but that last product is leaving. And so actually, you could have taken the original number and subtract off whatever the final number is, and you'd figure out how much mass of carbon dioxide you put into the air. The one on this side right here is also slightly losing mass too. It hasn't lost nearly as much. It's lost, significantly less. You're still going to get some gas that escapes out of that balloon, but you can see that this is a lot closer to following the law of conservation of mass because we have taken a lot of that gas and put that into the balloon. You can see the balloon expanding. So law of conservation of mass, you cannot create or destroy mass before or after the reaction. When you're looking at a chemical equation, that is shown because the amount of atoms at each side are the same. In the lab, you should actually measure that before and after a reaction, all of the products and the reactants are equal in mass. You have not gotten rid of oxygen or carbon or anything like that. You have just made new forms of it. In this case, we made a gas. Again, not perfect. If we had a tighter seal, you would have exactly the same mass before adding the Alka-Seltzer as after you're adding it. But you can see a pretty decent drop from after the reaction compared to without having a balloon on top of it. All right, there's your lab experience. Okay, so
Okay, we will see a couple examples. So one more time, we know according to law of conservation of mass, mass cannot be created or destroyed. So the starting mass should be equal to the ending mass and the starting mass. They should be equal. So the number of atoms in the reactant side should be equal to number of atoms in the product side. then you can say that a chemical reaction obeys law of conservation of mass. That is completely balanced. The equation is balanced, equal, before and after, same. Okay, so look at this example. A chemical reaction is given. So let's count how many iron, oxygen, carbon atoms are there before and after. Do you see? Before there are four iron, but after there is only one iron, and there are six oxygen before, after six oxygen, check. Before only one carbon, after it says three carbon. So something is missing. So it's not obeying law of conservation of mass. So the answer equation is not balanced. It's not balanced. How do you know it's not balanced? Because the number of atoms in the reactant side doesn't match the number of atoms in the product side. So in the assessment, I might give some chemical reaction. I might ask you whether this chemical reaction obeys law of conservation of mass. Is it balanced or not balanced? So check about that. So you have to find what is the number of atoms before and after. If they're matching, you say they are balanced. If they are not matching, you say it's not balanced, and it doesn't obey the law of conservation of mass. We will see a couple more examples. Okay, here you go. Let's count the number of atoms before and after. Then we will see whether that's balanced or it obeys law of conservation of mass. So let's pause the video. Okay, so are you ready to check the answers? So there are how many nitrogen left side? That is reactant side. There are 2 nitrogen, 8 hydrogen, 1 sulfur, 4 oxygen. And the product side, there are 2 nitrogen, 8 hydrogen, 1 sulfur, and 4 oxygen. So you would say the chemical equation is completely balanced. It obeys law of conservation of mass. Let's see one more example. Okay. I pause the video. You try, then we'll check the answers. Ready for the answers? Okay. So how many sodium? Let's start from sodium. There are 6 sodium, 1 phosphorus, not 1, 2 phosphorus, because you have to multiply by the coefficient. Then how many oxygen? 4 times 2. It is 8 oxygen. How many calcium? 3 calcium. How many chloride? 2 times 3, 6. Come to the product side. How many sodium? 6 sodium, 6 chlorine. Okay, let me write 6 sodium and 6 chlorine. And how many calcium? 2 times 3. So that is 6 calcium. So how many phosphorus? 2 times 1. 2 times 1, 2. Then 2 times 2, 4. So 4 phosphorus. And how about oxygen? 2 times 4, 8. Then 8 times 2, 16. So now you tell me, is it balanced or not? So the equation is not balanced. See, they have different number of phosphorus. In oxygen, they are not matching. Calcium numbers are not matching. So I would say this chemical equation does not obey law of conservation of mass. It means it's not, that is, it's not balanced. Now we'll see some different kind of examples. Okay, so you use the law of conservation of mass to fill out the missing information in the table below. Use the example 1 as a guide. So the left side, they have given mass of reactants, right side mass of products. See, up to this. Up to this mass of reactants. Other side mass of products. So the first one already done. Hydrogen 3.4 grams, oxygen 10 grams. Then you get 13.4 gram. Check. Okay. You will try the second one. And you have CH4 methane, that is 12.2 grams, oxygen 14 grams. So the reactant side together. So you want me to pause the video? You can give me the answer. Okay, so let's take carbon dioxide is X. So now I'll work out the problem here. It's just solving the equation, right? With one variable. So 12.2 plus 14 equals X plus 20. So what is X? $26.2. You might be having the answers. So X becomes X equals 6.2 gram. Okay, let me write it. X equals 6.2 gram. Okay, so this is the second problem. Okay, now you try the third problem. If you have an answer, you can share it with me. So HGO 23.6. On the product side, what is the mass of mercury if oxygen molecule is 13 grams? So now you have to subtract left side 23.6, right side only 13. Then you have to subtract 13 from 23.6. So you'll be getting 10.6 grams. You have? Okay. Let's answer the fourth one. So you have lithium. You don't know how much is lithium. And you have oxygen 5.7 and gives you 24.6. So that is X plus 5.7 equals 24.6. So now we have to subtract the 5.7 from 24.6. So what is the answer? $16.7, that is 9. Okay, 13 minus 5. So 18.9. So write the answer. Okay, give me answers for the other two problems. So 18.9 grams, one of the reactant, other reactant is 11.1. And you're getting carbon dioxide and water. So it's a combustion reaction. See, you have carbon dioxide and water. So what is the mass of carbon dioxide? You have answer? So add this 18.9 and 11.1. So 30. Then you have to subtract 15.6 from 30. So you must be getting 14.4 grams. Am I right? And go to the last one. Okay, you have aluminum hydroxide. You don't know what is the mass, and it decomposes and it gives aluminum oxide and water. And 21.8 grams of aluminum oxide, 9.7 grams of water. So what must be the mass of the reactant? So you have to add them together. 31.5 grams. So does it make sense? So I have given some practice problems. You can practice. I have uploaded in the link also. So you can practice the law of conservation of mass and how to count the number of atoms and everything using this. Hope this helps.